All right. So just real quick, before we get started, the general plan today is I've got like a short PowerPoint. We're going to do that, hopefully 30 minutes. I don't know if you've been to my other review, it's going to be the same thing. We're going to spend hopefully 30 minutes here and then just do an hour and a half of just straight code. I've always found that code has been much more useful in helping me understand things than seeing PowerPoint slides. And I've gotten a bunch of feedback that said that's like true as well. But so yeah, we're going to spend like this. This is just going to hit some basic things that I get a lot of questions about. So if you have like specific questions, just hang on until after the PowerPoint slide. But if we hit something that you have a question about, like during the slides, ask then, don't ask later. But if you have general questions, we'll do that after the slide, and then we'll just do a whole bunch of examples. I've got a whole bunch of just like code up examples prepared for you guys today. So with that being said, are there any questions before we start? Everyone good? All right, so first things first, it's not exhaustive. We only have 2 hours. There's no way we can go over everything. Also, I'm a student, and I can make mistakes. I've tried my best to make this perfect, but if you're not sure about something, get a second opinion. You're responsible for your own misunderstandings. This is a slide specific to the in-lecture class. So if you're in the online class, ignore me for a second. But your exam's Friday at 10 a.m. Don't get there late. Don't forget your note sheet. And also, he says that you can bring a non-programmable calculator. I would definitely take advantage of that. You don't want to be worrying, like, what's 107 plus 24 on the exam? Like, you don't want to have to worry about that. Just bring a calculator. And also, he's explicitly said that these things are not on the exam. So regular expressions, character representations, NetBeans debugger, IO streams, readers and writers, pass files, and directories. So don't waste space with this on your note sheet. Don't waste time studying it. It's all good stuff to know, but with respect to the exam, there's no reason to study it because he said it's not on the exam. Other than that, we'll just get straight into classes. So classes are just a construct of something, like a blueprint. Just a blueprint of like how you can lay out an object in real life, or something that you want to represent. Broken down to 3 main parts: fields, constructors, and methods. Fields are just like variables. Constructors are what you use to create an object, and methods are things that you use to act either on those fields or just to do something in general. Can be used to create objects, doesn't have to, but some important classes that I would know: math scanner, random, string, array, and collections are all things that I would just know like pretty much inside and out. They have a lot of stuff that's useful, and like if you get asked a question where you have to write something up, it'll be a lot easier to call collections.sort than to have to code up your own sorting algorithm on there and then use that. So moving on, primitives are not objects, so don't get them replaced with their wrapper classes, which are objects. But it's just like everything that gets highlighted in your editor, int, double, float, byte, long, boolean, all those like just basic things that you type out, and they're not capitalized, are your primitives. Objects. An object is an abstraction that has state and behavior. So basically, you create a class, you define its state and behavior, and then you create objects that now have that state and behavior. So like, what that means is, so like your state is basically your instance variables, where like things that are specific to that class, or specific to that object, I guess is the better way to say that. Let's say you had a bicycle, I guess is like the quintessential example. Bicycle could have, like 2 gears, it could have 3 gears. So like that would be an instance variable, like number of gears, and each object can have each object or each bicycle has its own number of gears, is basically what that kind of means. And then in Java, we use classes to create objects by using the new operator and calling the constructor. The constructor returns an instance of the object, and objects are references. Objects are references. Does everyone understand what that means? Objects are references. It's a pointer to like somewhere in memory. The object is a pointer somewhere in memory. Or I mean, not the variable that has your object is a pointer to somewhere in memory where that object is stored. So like when you're using the dot operator to say like, bicycle dot number of gears, you're saying I want to go or not bicycle, let's say we had bicycle B and then created an object, so new bicycle. When you say B dot number of gears, you're saying, I want to go to the place in memory where B is and then get its number of gears field. Does everyone understand what I mean by reference? Okay, that's a very important thing to know. So quick question, how can I tell that a method is a constructor just by looking at it? There's two main things that let you know that something is a constructor. Someone give me one. No return type. Same name as a class. That's the two main things. It has no return type because it's returning an object of that class. And it's the same name of the class, like exactly. So if it was capital B bicycle, the constructor would be capital B bicycle and then parentheses for your parameters. And you put your parameters in there. All right, so constructors create and initialize objects. You know the constructor is being called every time there's a new keyword pretty much. When is there a default constructor? When does a class have a default constructor and when does it not? When it has no input parameters, what do you mean by that? Like when it doesn't have any in the parentheses. Okay, so yeah, so you could define a no argument constructor that has literally no arguments, but I'm talking about the one that's built into Java, like with a that comes with a class. Like when does a class have a default no argument constructor, I guess is the better. When you don't define one yourself, yes. So if you don't define a constructor, Java will automatically make a constructor for you that all it does is creates the object and sets all of your instance variables to their default values. So example of a constructor call, scanner sc equals new scanner, and then it's opening it on a new file from input.txt. And then example of a constructor, this one's just taking in 3 parameters, year, make, and model, and setting its instance variables equal to those parameters that have been passed in. Pretty simple. Should know that. So fields are what I've been talking about with objects. They're attributes that make up your object. So back here, year, make, and model are all fields of the car class. They make up the state of the object, you could say. You can also have static fields. We'll talk about that. But fields in general are just like the variables that you have inside of your object. Methods make up the behavior of an object, or well, of a class, but it could also be of an object. Usually accomplish something that you want to do. So some important methods that I would know, math.random, a lot of the string methods like substring, there's like char@, a whole bunch of things in there that would be useful to know. Array collections methods, like I've already said, know the arrays in the collections class. Scanner methods. Scanner's like the best thing in Java. It's like how you get all your input pretty much always. There's other things, but like 9 times out of 10, you're just going to use a scanner. And then knowing methods could sometimes like make or break a question. So like if you don't know how to get the next thing from a scanner, how are you going to read in the input, basically? Like you're pretty much just dead in the water if you don't know how to do that. So definitely know stuff like that. Static. So static, the static keyword, someone tell me what the static keyword does. Yeah.
It makes it so that a variable for an object is synchronized across all instances of that object.
Awesome, perfect. Like that's really good wording. I like that wording. So it makes it so that a variable is synchronized across all of the. That's what he said. It's synchronized across all of the objects of the class that have been created. Is a static variable there if you haven't created any objects? It's not. So if I say like static A in a class, and then I wanted to like say, so let's say we had class whatever, just like literally whatever, and then inside that I had static A. If I said whatever.a, would Java let me do that? Yeah, so Java would let you do that. A static variable or a static method is always there. No matter if you don't create an object, it's always there. So you can literally type in, like, I have an example later, but you can type in the class name dot like that variable, and you can access that variable or that method. So like math.random. Did we create an object here? Is there any constructor? Do you guys see anything like that? No, it's just we're just saying the name of the class. We're saying the name of the class, which is math, and then we're saying .random. I want the random method. When you see something like that, you know it's static because you're not using an instance variable or like an object to call that method. So like a static is always there. It's no matter what, even if you haven't created an object. Hey, what's up?
Is there only one instance of that? Like it's not copied on everyone, right?
Yeah, so that's, here, I'll draw this. I think drawing this is usually better. Make sure this comes up, you guys can see it. All right, so let's just say we had, like this is our class, and let's just call it, we'll just call it like just whatever. This is our class, doesn't matter. And then we have a static A, and then or the static int, sorry, that's kind of hard to see. And then here's our box for it. And then we have just an int b. And then here's our little box for it. We're just going to make this just as like a little representation. So when you first, like when you say, you know, Java whatever, right? We're saying I want to run the whatever class. I want to go into its main method. I want to run it. Java, what it does is it'll look through your blueprint, and when it sees the keyword static, it'll go, oh, okay, this is static, so it's going to be here no matter what, no matter if we have an object of this class or not. So what I'm going to do is I'm going to go over here. I'm going to create it. This is our A, and then I'm going to give ourselves basically a pointer to it. I'm going to create it, and then I'm going to, instead of leaving the A in here, I'm going to give our whatever class a reference to A. And now it's over here, outside of it, just everywhere else. It's somewhere else, doesn't matter. So then when we go to create an object, so let's create an object C, and it's of our class whatever, right? So this is now an object. When we create an object C, we're going to start running through our blueprint. We're going to see static. So we're going to go, oh, that has to be already created because I'm creating an object. So that already exists. So if here's our little box for A, what I'm going to do is I'm going to go up to my blueprint. I'm going to take this reference and put it here. So there's only one instance of that A, and no matter like if I created another object D, its A would also be pointing to here. So then if I said like C.A is equal to 5, this would get set to 5. And everyone's, no matter where you access it from, it's always going to be 5 as long as it hasn't been changed. Does that make sense? So then after that, if I did D.A is equal to 6, we would come up here, and change this to a 6. Does that make sense? It's basically in its own little land. So when you see static, it's in its own little area, and it's just like everything shares it. Same thing for a static method. It would have its own little box over here, and everyone would share that method. Everyone good? What's up?
I just got here. How far along are you right now?
We are a few slides in. You're fine.
Is that where do we access that?
It's posted on both the UCF Study Union website and my website.
Which one do I do then?
It doesn't matter. Just ucfsi.wordpress.com, and then you just go to where I am. Let's get back onto the slide. Oh, of course. So everyone understands static? Static good. Cool. All right. So method overloading. Methods can have the same name as long as they have different parameters. So basically, if you have a different method signature, you can define the same method to have a different number of parameters. You can have like the same method, it does the same thing, but it does it for different things. So a good example is like, let's say you want to define your own max function. You could define a max function that takes in 2 parameters and returns the max of those 2 values. And you could define, again, a max function that takes in 3 parameters and returns the max of those 3 values. It's kind of the same thing. What's up?
Well, is there any reason that you would want to code it like that and give them the same names? Are we assuming that they're a part of different classes?
Well, no, they could be in the same class. Well, it wouldn't make sense for this to be in different classes because we're doing specifically method overloading. But like the reason you would just want to do that, like that's just like a contrived example. But there's reasons where like you're doing the same thing, but you would want to do it for different objects. So like you could say like the collections.sort. You'd want to have it defined for array lists, but you'd also want to have it defined for something else. Or like arrays.sort, you want to have it defined for every type of array.
And how is this different from overriding?
What do you mean by overriding? So I think I have a slide on that, but that's a completely different thing. It's just method overloading is, oh yeah, I see, that's completely different. Yeah, we have that later. But it's just like method overloading is when you have the same method name and you have just a bunch of different parameters that you pass to it that the method is basically doing the same thing, but it's doing that thing on different objects or different variables. Good? Access control. So I pulled this straight off of the Java API. I like this. I think this is very clear as to what the access modifiers are doing. So basically, when you have public, your class can access it. Everything in your package can access it. Your subclasses can access it, and then everyone else can access it. And then when you're protected, you have the same thing where your class and your package can access it, and your subclass can access it, but it's just not available to everyone else in the world. And then no modifier, that's implicit package private. And that's when your class and your package can access it. And then private is only inside of your class. You can access it. Is that good for access modifiers, everyone? You can find this literally, like if you Google Java access modifiers, it's like the second link. It goes to the API and it has this, and then it has like a little example. Interfaces. So there's special classes that are like completely abstract. The fields are always static and final. The methods are abstract. It's basically like, I don't know, I think C is a prereq for this course, right? So in C, you have header files. Usually they talk about that. It's the same kind of thing where you're like defining, oh, I'm going to have these functions inside of this C file. It's the same kind of thing with interfaces. When you say implements an interface, I'm just saying, I'm going to provide implementation for these methods. It's the same kind of thing. But use the implements keyword. You don't have to specify that methods are abstract since everything is interfaces abstract. It's just kind of implicitly known. Some important interfaces are comparable, iterable, list. I wouldn't really worry about knowing like the ins and outs of iterable and list. I would definitely know how to use comparable. And we have an example with that later. And then when you implement an interface, it requires you have blah, blah, blah. Everything that I've already said. So comparable, you're using it, when you say something's comparable, you're going to use that to sort the class that you've created, basically. It's used to compare one object to another object so that you can compare them and then sort accordingly, if this one needs to go in front of this one or the other way around. And we'll do an example with this later, so I'll just kind of smooth over that for now. Inheritance, inheritance is really what this whole course is about, basically, where you extend classes and you create subclasses and you have superclasses and he had the one example where you had transportation, and then in transportation you had car and truck, and then under car you had a taxi. And like transportation, or a car is always a transportation, but transportation is not always a car because a transportation could be a truck. And the same thing, a car or a taxi is always a car, but a car is not always a taxi because you could have a car that's just a car. It establishes a hierarchy of inheritance, basically. As you can think of it as a tree where the highest up thing is object, because we know that everything extends object in Java. We know that, right? It's been said a million times. Everything in Java extends object, and as you climb down the tree, you get more and more and more and more specific until you finally reach the thing that you want to use, basically. So like you climb down the tree and you finally get to integer, and now we can use integer. If you want to like pull parallel, like if you want to like example, it's kind of like if you've taken biology, how you have the whole, oh God, what is it called? The whole like the hierarchy tree of like the, oh man. Kingdom, phylum, that whole thing, where you get all the way down to the species, and then you're finally at, you know, us humans, right? And then subspecies would be just like different humans. But it's like the same thing, where you climb down, and as you get further down into the tree, you're more and more specific with what you're talking about. Does everyone kind of understand what I mean when I'm talking about inheritance? Everyone good? All right, abstract classes. Share functionality with regular classes and interfaces. It's basically a class that inside of it has a method that we haven't provided implementation for. We say, we're gonna create a person, and then we're going to give person, you know, every person's going to have a name, and every person's going to have an age. And then we're going to extend that class, and we're going to create employee, and every employee is now going to have an ID. We don't want to just create persons, though, because just people isn't useful to us. We're just doing that so that we can, in case later we want to create like a different type of employee, we don't have to go write the whole class again. We can just use that same blueprint and create another employee that would have, I don't know, something else, not an ID, maybe like a key card number or something. Yeah, what's up?
What is the, I think you skipped, what does the this keyword exactly mean? 'Cause I never was.
The this keyword?
Yeah, what exactly does that refer to when you use this?
So when you're using the this keyword, I guess you're talking about back here, don't forget this on the bottom of the slide. When you're using the this keyword, you're saying this object, where I am like right now. So like in this example, when you say this with the parameters, you're basically saying, I want to call the constructor on this class. That's the only, when you have this and then open close braces, the only thing that you can be calling is a constructor. And the only place you would use that is inside of a constructor, pretty much. So there's like.
There's a global variable with the same name, and then you have to clarify or talking about the.
Yeah, so we had that.
Of that variable.
We had that back here, right here, when we were in the constructor. We were saying this dot year equals year because the class has the name of a variable named year, and then we had a parameter called year, so we have to distinguish between the two by using the this keyword.
Specific instance of that class?
It refers to the instance that you're currently in.
Yeah, that's what I.
Yeah.
Also, right after that, on what we were talking about just a second ago.
Uh-huh.
So, if abstract methods can't be instantiated, how can we still use them?
You can't instantiate methods, so you can't instantiate. Do you mean like abstract classes? How you can't instantiate abstract classes?
Well, if an abstract method if they can't be instantiated, then what are they for?
They're used to be like as a blueprint. Like so, in my example, we were saying we had an abstract person, right? We don't want to create just people. If we're a company, we don't want to just create people because that's not enough information for us. We want to create employees or managers or something like that. So you create the person because every person is going to have the things inside of that person class, right? So every person's going to have a name, every person's going to have an age. That's stuff that you don't want to have to rewrite later. So you're going to make it abstract and just like have it there so that you don't have to redo that later. And then when you create an employee, you're going to extend person, and now you're going to provide implementation. So like, let's say we have, we define an abstract method, lookup, that lets us look up the stuff that's inside of that class. Whatever, it doesn't matter, because it might be different. So like, it might be like when you create an employee, there might be other things that you want to provide in that lookup. So you create an abstract method saying, here, we're going to define this so that everything that extends this is going to have to either give us an implementation for lookup, or it's going to have to be itself abstract.
Are those the only thing that we were extending this semester, or was there like anything else? Or
You can extend regular classes too.
Well, why do they need to be? I'm still not understanding.
Abstract when it's
the information in an abstract class
you can't.
if you can't instantiate.
You don't. You use it in its subclasses. So you have the abstract person. We're not going to create a person. We're going to create an employee. The employee extends person, and it has all of the fields.
If you want to make an object of this, you would have to make a subclass, basically.
Yeah, you'd have to create a
Have
subclass
instance
to that you would then create
So you have
objects
a
off
movement
of.
for something broad. So like, if you had a genus abstract class, species have a common genus. You can't create an instance of a genus, but you can create an instance of species by extending the genus class, basically.
Yes.
Okay.
Yeah. Everyone good with abstract? I think that was a very long-winded all right. Exception handling. So basically, exceptions are exceptional events, or like some people like to call them. They're just things that happen that you either need to handle or the program's going to crash. So a good example of something like that is an array out of bounds exception. I'm sure everyone's seen that, an array out of bounds exception. You try to access something, let's say the array is of length 3, and you try to access index 3. That doesn't exist. You're going to get an index out of bound exception. You either handle that in a try-catch, or the program's going to be like, I can no longer continue because you've done something illegal. It's not allowed. You can't do that. Another good one is like file not found exception. So if you're trying to open a scanner on a file and it can't find the file, you either need to handle that or the program's going to crash because you haven't provided a means to handle where the file hasn't been found. So basically you'd use that. We have an example with this, but you do that with a try-catch block. There's an inheritance hierarchy with exceptions. So like every exception extends exception. It's kind of like every object extends object, every exception extends exception. Exception is the highest point of exceptions. So that's basically like exception also extends object, but like exception is like the entry point for all of the other exceptions. So if you want to be extremely general and just say, I'm just going to catch every exception ever and handle it this way, you can do that, and that's how you do that. You'd use catch exception E. Wrapper classes. So these are what I was talking about earlier. These are the classes that you can create objects of that hold our ints, our doubles, our floats, our longs, everything like that. Java kind of auto boxes between the two. So when you create like an array list of integers and then you pass it, the literal 5, Java knows to go, okay, I'll take this int 5, or I'll take, like, let's say you said int a equals 5, and then you pass it a. It'll go, okay, I'll take this a, and I'm going to convert it into a wrapper class of type integer, and then put that into the array list. Does that make sense, everyone, what I'm saying? Java is really good about switching in between the two. So if you say int a is equal to an integer, I'm pretty sure usually it'll just figure it out. But yeah, they just wrap up their associated primitives, especially useful collections, like what I was saying, where you have an array list of integers. You can't say an array list of just int. You have to say, because you can only create generics, you can only use classes. So you have to just say array list of integers and then pass in the integers to that. Everyone good?
So you can only use classes, not just any reference type?
Oh, it's any reference type, yeah. It's just, that's what I meant. That's because objects are references, so when you create like an object of a class, it is a reference.
Why do we need wrapper? Like, what's an example of a program that would use a wrapper class?
What I just said, where you have an array list of integers. You can't create an array list of just int. If I said array list and then put the two little brackets and put just int, the primitive, in there,
Why can't you just do int array?
because it's not an array list. You want, let's say you want an array, int array.
I mean, like, I didn't mean to say that. I meant, like, I could have sworn that there was something more complicated involving wrapper classes besides just array list, because I know that's when we first saw.
Well, it basically, it turns it into a reference, so you could also use it to like pass a reference to something into a method so that when you get back out, you have the same
I could have
thing.
sworn there was something more complicated about using wrapper, like outside of array list. I thought there was something else. I think that's it.
Yeah, but that's what an array list of integer is. It's generics. So I have a really good example, which some I think of you have seen, but I like it too much, so we're gonna do it again. Where we do generics, but you basically use it for generics, but also just in general, it's just something that is there so that you can use it if you want to, because it turns it into a reference. So you could say that a method takes in an integer a, and then outside of that method, you could have defined, integer b equals, 5. Pass it into that method. That method does something to it, and then when you come back out of that method, your original reference has now been changed inside of that method. It's kind of the same thing as pointers. It's basically in C, when you have an integer pointer, this is the integer pointer equivalent in Java, is an integer. It creates a reference to that thing rather than having it be a primitive that doesn't have a reference.
I was just about to mention, does anybody know what W3 resource is?
What are you talking about?
It's just it's extremely helpful resource.
Oh, like for just like Java stuff?
A bunch of languages.
Okay.
It's not the same thing as the other website that people use for like HTML, JavaScript.
Okay, awesome.
But
Yeah.
I think it's the same people.
Well, definitely can look at that if you need some more stuff.
It looks like they update it pretty frequently too.
All right, moving on to collections. This is the list of things that I would definitely know. These are all collections that I would just definitely know like how they work, what they do. So array lists, it's just a variable length array. Stacks and queues, he's talked about that. The big ones I would say are hash set and hash map. You will use those extensively forever because they're awesome, because they just give you order one access to things, and you can just look it up. And you'll learn when you take CS1, you'll learn about hashing and how this works. But hash sets and hash maps are probably one of the most useful things I use that all the time in Java. And then tree sets and tree maps, which are basically binary trees, which you also learn in CS1. But the difference between a hash set and a tree set is a tree set has an ordering, a hash set doesn't. A tree set takes a log n. You'll learn big O notation in CS1. I guess it's not a prereq for this course. But a tree set, just know that a tree set is slower than a hash set for getting things and putting things in, and a hash map, and a tree map is slower than a hash map for putting and getting things in. That's basically just like the two biggest difference. The tree sets and the tree maps have an ordering. The hash sets, the hash maps don't. The hash sets and hash maps are faster than the tree sets and the tree maps. Do you have another question?
You kind of answered it. So you're saying that one is slower than the other because one doesn't have to sort anything?
Yeah. So the hash sets don't have to sort. That doesn't sort. You can't rely on the things you put in it being sorted. Everyone good? Collections. So stacks and queues. I kind of like to just do this. He's also talked about linked lists. Linked lists are a bit complicated. I would just know they're kind of like chains. I just think of them as that. That's how they work. But stacks and queues. So for stacks, how I like to think of stacks is let's say you're helping your grandma move, and you've packed up all of her fine china into boxes, and for whatever reason you've decided that as you pack it up into boxes, you're going to stack them all on top of each other. Okay? That makes sense? So let's say this is a box of fine china, and then we pack up another box and we put this box of fine china on, and then pack up another box and put this box of fine china on. So would you want to go and grab this middle box out? No, because this box would fall and you'd break all her fine china, and then she'd disown you from her family, right? So you have to take this one before you can take this one. So basically, like, it's just like how it works, how a stack works is, let's say you've stacked up things, it's last in, first out, or the last thing that you've put in is the first thing that will come out. That's how I think of that. So like, we stack this on, and then if we want to take from the stack, we have to take this. When we take from the stack, we always take from the top. And then we take from the stack, we always take from the top. And then now we have access to this one, which has the plates that she wanted for dinner or whatever. And then we can take this off, and now we've done our things. What's up?
What do you use a linked list for? It sounds a little tedious.
Linked lists are used for a lot of things. The main thing that linked lists are used for is when you have a lot of things that you want to put in memory, but your memory is not necessarily contiguous. So like when you create an array of things, that memory has to be contiguous in memory. It has to be, because it has to be like a contiguous block of memory. So let's say you had like 16 gigabytes of RAM, and you wanted to put 16 gigabytes worth of stuff in there, or 15 gigabytes worth of stuff in there. You're very unlikely to have a 15 gigabyte block of free memory. So what you use a linked list for is to be able to jump around in that memory and have your smaller pieces all over the place, but you're still able to use the entire 15 gigabytes of memory. But does everyone understand stacks? Stacks, it's just literally stacking. And then queues are your regular line in a store where the first person that got in the line is the first person to be serviced. That's how I think of that. It's the same kind of thing where you can just turn this on its side, and someone gets in line, and then the next register is ready, so this person gets serviced, and then this person gets back in line for whatever reason, and then the next register is open, so this person gets serviced. That's how queues. They're just regular lines.
So queues first in, first out, stacks last in, first out.
Yes. Oh, I forgot I had a slide on this. So here's a whole bunch of words and pictures about everything that I just talked about, pretty much. Event handling. So this was when he talked about GUIs. I don't think he's going to ask you a whole lot of stuff about GUIs, but if he does, it would probably be about event handling. Just know that you can register listeners. So like a mouse listener, action listener, key listener. And all it does is just event driven, so like when something happens, it'll handle it. That's the best way I can kind of describe it. It's just like when they press down the E key, or the R key will reload our gun or something. That's just like the basic gist of what they are. They're listening for an event. And then threads. So basically, they're implements the runnable interface, which has the run method. And threads are used for running multiple things at once. So you want to do a whole bunch of things at one time. You create a bunch of threads and let them go off and do their things. And then once they've all done, then you end your program, or you handle all the data that they've generated, or something like that. Also know the synchronized keyword and what it does. Can someone tell me what the synchronized keyword does? What's up?
It makes it so that only one instance of the word only one instance of class can access that variable at a time.
Yeah, it makes it so only one thread can access like the method or whatever is defined as synchronized at a time. So
Isn't that just basic concurrency?
yeah, it's concurrency. It's exactly what it is. But it just makes it so that only one thing can access it. So like let's say you had, for whatever reason, you have your own wrapper class for an array, and you have your own array list. Array lists I don't think are synchronized. They might be, but let's just pretend array lists are not synchronized. And then you call the put get, or you have an array list of A, and you call the a.put method, and you pass it something in one thread, and the other thread also calls a.put and passes it something. If they get called while one thing's putting something, and this thing tries to put something, you're going to end up with a collision where one will overwrite the other before the pointer for where the next place is open is updated. So if you call the same array list .put in two different threads at the same time, you basically overwrite what one has written. So that's what you use the synchronized keyword, is to make sure that only one thing can be putting or getting something at a time. That way you don't run into collisions where one thing writes something and then another thing writes something right over it. And then that's it for the PowerPoint slides. Are there any general questions? You guys have anything you want to talk about in particular before we move on to code?
I was actually going to ask if you could share this link with everybody, because I think it would help a crap ton.
I'll put it on my website if you give it to me later.
I don't know how to do that.
I will. I'll put it on my website. You just give it to me after we're done. All right, so I've got kind of examples ordered from earliest material to latest material with regards to the in-class. I don't know if you're in the online class, it might be a little bit jumbled up. But do you guys have any specific thing that you want to talk about before, or do you just want to go like in order? In order?
That makes the most sense.
Okay. All right, so first thing I've got is this class that is called coin flip. All right. Oh, wow. All right. Let me change that real quick. Even that's still kind of small. Oh. Yeah, that's better. No, I want to do profile preferences and custom font. No, I am zooming in. It's just I have to change it inside of this, and we'll just keep that because I don't want to change that. All right, so in this coin flip class, we have a static method flip that I want to return true 50% of the time, and I want it to return false 50% of the time. And then in the static method loaded flip, I want to return true 20% of the time, and then false 80% of the time. So I think one or two of you have seen this. But what do we need to do, like, what do we need to do this sort of, what do I say, like probabilistic type thing? Anyone have any ideas what we need to make this happen? We need random numbers, yeah. I don't know if I didn't say that in here, did I? Yeah, whatever. So we need random numbers, basically. So what are the two, math.random, what is the other way that we can get random numbers? The random class, yeah.
Java,
So
java.util random.
yeah, the random class. So you can either use math.random or the random class. I prefer math.random over the random class, and that's what we're going to use. The random class does make it easy, but I think knowing math.random and how it works is just quicker to use. So we're going to use math.random. So math.random returns a number on the range 0 inclusive to 1 exclusive. So that basically means we can get 0, and we can get everything up to 1, but not including 1. So like 0.999999 going on forever, but you'll never actually get 1. So does anyone have any ideas on how we can use that? How that we have the range 0 to 1, how we can use that range to get 50% of those for us to return true and 50% to return false?
Quick question.
What's up?
I remember him saying not to use the asterisk import method.
I don't think he's ever said that, but you can just be explicit and import all the specific things if you want. I just do that because it's quicker.
But is there a downside to doing that?
There's a downside like where it'll import a whole bunch of things that you're not using, but I just do that because it's really quick. Any ideas? Yeah, and yeah. So the question was, how can we use math.random and its range of 0 to 1, inclusive on 0, exclusive on 1? How can we use that, or how can we split that up so that we have 50% of the numbers returning us true and 50% of the numbers returning us false?
So
If it's less than 0.5, so how would I say that?
if math.random parentheses is less than 0.5, return true, else return false.
do you guys think? What's up?
Does random know the ranges from like 0 to 1 or whatever we want?
What do you mean?
I think I'm from online class. We use like random next in most of the time. That's the other class.
That's the random class.
How does this random know that you only want to go up to like it won't give you like 4 or something like that?
Math.random is defined. Math.random always returns a number, like it's defined as it'll only return a number from 0 to 1. And that's just, it's defined like that. 0 being inclusive, 1 being exclusive. Do you guys think that this is split is right? Does that make sense? What he's saying right here is, if our random number from 0 to 1, inclusive, exclusive, if our random number is between 0 and 0.5, inclusive on 0, exclusive on 0.5, because we said just strictly less than, we're going to return true. And then otherwise, if it's greater than 0.5, so including 0.5 onward to 99999.9999999, we're going to return false. Does that make sense? Does everyone agree that that is a 50-50 split? Yeah, so that's what's going on. That's exactly what's happening. You've created where it's going to return true 50% of the time, return false 50% of the time. So something that I want to point out, when does this statement get executed?
From 0 to 0.49.
Yeah, but like specifically just like in terms of this, when does this get executed? When what is true? When this condition is true, we'll execute this statement. So when this condition is true, we're returning true. And then similarly with this, when does this statement get executed? When this statement is false. So we have a false here, and we have a false here. And then we have a true here, and then we have a true here. So do we even need to do this if-else statement? You can just return the condition, right? So you can just get, because we've defined it like this, where this happens, we can just get rid of all this. And return it. When I first saw that, I freaked out. You can do this in C too. C will like return an int and it does its thing. But because the Boolean operator returns a Boolean, I don't know, I always thought that was awesome. So moving on to loaded flip, how can we do loaded flip now, knowing what we've known for flip? And I don't want an answer from you, I want an answer from someone else. It's 20% of the time returns true, 80% of the time returns false. So let's just say it's like a loaded coin. Less than 0.2, like this. So same thing, just less than 0.2. Does that make sense? Everyone agree that's what that's doing? 20%, 80%? You guys can read this, right? Everyone's good? I should ask that first, I guess. But yeah, so that's how you would do that. Now it'll return true 20% and false 80% of the time. So up here, we're just going to run this, and we're going to do 10 regular flips and 10 loaded flips. Different. And then right here would be loaded flip. And we can go over here and we can compile it. Ooh, I typed in an L instead of parenthesis or a semicolon. Compile it. Where else did I type an L? Oh, I just didn't delete the L. Jeez. There we go, compiled. Now we can run it. And so we got 6 trues and 4 falses there, which that's about right. As you have more runs, it'll get closer and closer to 0.5. And then down here we have the exact split that we're looking for with 2 trues and 8 falses for our exact 20/80 split. So this is just like a random number use example that I would just understand how to use math.random and the random class to get random numbers, and then you could do the same thing with like numbers from 1 to 100 or 0 to 100. It's just applying it in your specific instance and like what ranges you have. But is that clear? Does everyone understand? What's up?
Could you please explain how that return statement returns 50% true and false?
So the return statement right here, this one, how it returns 50% of the time returns true, 50% of the time returns false. Okay, so math.random has the defined range of numbers, right? It can return a defined range of numbers. It can return 0 to 1, inclusive on 0. So it can return 0, exclusive on 1. So you will never get exactly 1, like 1.0. You'll never get that. So by saying math.random less than 0.5, we're basically cutting that number range directly in half. We're saying I'm going to have the number range 0 to 0.499999999, and then I'm going to have the range 0.5 to 0.999999999. So by splitting it directly in half, we now have 50% of the numbers over here, probabilistically, and then we now have 50% of the numbers over here. Does that make sense? So now that you have two 50% splits, by doing this, because it's a random number, we don't know where it's going to land. We just have the probabilistic, it's going to land 50% of the time over here and 50% of the time over here. We now have that 50-50 split, and what we're doing is we've just decided the lower range, we're going to return true. We're going to define that as our true region, and the upper range, we're going to define that as our false region. So we've assigned 50% of the values here and 50% of the values here. So by doing that, we now have like a 50-50 split, where 50% of the time we're going to get true, assuming that our random number is truly random. 50% of the time we're going to get true, 50% of the time we're going to get false. It's just going to 50% of the time it's going to land in this range, 50% of the time it's going to land in this range, statistically. Does that make sense? Yeah, what's up?
Could you explain the static for methods for me? Why do we have static? What would that do for the methods, like public static?
Oh, so if we didn't have static, Java would complain. So let's do that. Oh. So if we didn't have static and then we try to compile this, Java complains. Uh-oh. Over here, error. Non-static method flip cannot be referenced from a static context. Can someone tell me what that means? What are we trying to do? It's not allowed.
Trying to access something.
What were you going to say?
Is it because the main function is static?
Yeah, so inside main, we are inside of a static context. We haven't created an object of coin flip. So if we try to call, if this isn't static, if we try to call a non-static method, that doesn't make sense because we're not inside of an object. A non-static method works on the object's instance variables, or well, it just works on that object, right? So by defining it as static, we're saying this is transcendent of all instances. It doesn't matter. It doesn't have anything to do with instances of this class. It works even if you have no instance. So because we're not creating instances of because we're not creating instances of coin flip, we don't need to make these methods static, or we don't need to make these methods, or we need to make these methods static because we're not creating objects. Yeah, so if we wanted these to be non-static for whatever reason, there's no reason they wouldn't be, but let's just say, for just example's sake, we want these methods to be non-static. Up here, what we'd have to do is we'd have to say, right here, we'd have to say coin flip my coin equals new coin flip, right? Call a constructor, and we can call that because why? Why can we do that? Default constructor, why do we have a default constructor? Because what?
Well, we didn't define one.
Because we didn't define one, exactly. So we create a new coin, my coin, and then here we'd have to say my coin dot flip, and then here we'd have to say my coin dot flip. And now this will work, so we can do this again. We read Java C, and Java's fine, and then Java coin flip, and the same thing happens. Does that make sense? So like you could even define a constructor, right? So you could define a constructor up here. We could do public coin flip, and it takes in a double percent, we'll call it, for percent. And then inside of here, we'd also define a double percent as an instance variable, and then we would do this dot percent is equal to percent. And then we can use this percent value to set our loaded value. So we could set our loaded value. Instead of saying that this is now strictly, we're always going to be 20/80 split, we could now say that this is now our percent value of the defined percent value that when we create the coin flip, we're saying like this instance of coin flip will have the loaded flip value of whatever we passed in. Does that make sense? So now right here, instead of just saying coin flip, we'd have to pass something in. To make it the same, we would pass it in 0.2. And now it's the same thing that we've done where it's 20/80 split. And we can run it again, and it does the same thing. Everyone good? Understand what I just did? Makes sense. What's up?
I have like a nitpicky question, kind of.
Mhm.
Okay, so you said math.random does from 0 to 1, right?
Yes.
So wouldn't that be,
This could get set out of the range. We haven't done any enforcement, if that's what you're trying to say.
no, I'm saying like when we do math, say just like an initial question, we have math.random. So that one, say it's 50/50, right? First one's from 0 to 0.49, right?
Yeah.
And the second one's to 5 to 0.99. So isn't that second half only 49% because it doesn't go to 1?
No, because our first range, it's technically 49%, but we've taken the 100% of the range of values that are possible, so we've split it into two 50/50 splits. But because we've gone up to 0.499999, and then you have the same mirror image 5 to 0.99999, it's exactly the same. You've used up 100% of the possible values that could be returned, so you have that 50/50 split. Everyone good with coin flip and math.random? I'll post this later on my website, so you don't need to worry about that. I'll post the completed things. I'll literally just zip this back up. It's ucfsi.wordpress.com. I can show you later afterwards. But I'll post like everything that I type up today. I'll just zip this all back up and put it on my website. All right, so that's coin flip. Let's RM. So, okay, hello. Really? What is going on? Whatever. All right, moving on. So we've got sets and maps, class versus instance. Actually, let's start there. I was going to ask where you guys want to start, but we'll start with this. So this is just your general, what's the output of this program question. So in the side of this class, we have public static int A, and then we have public int B, and then we have a main method where we create an object. We set its set its A equal to 5, set its B equal to 6, print out A and B. Then we create another instance. We increment both A and B, and then we print them out. So what is the output of this program? I'll let you guys kind of devour. Any ideas? What's up?
5661.
5661? So we'd say right here, this would be 5, this would be 6, and then right here, this would be 6, and this would be 1? What do you guys think? Everyone agrees? 5661. So did we define a constructor here? One second. Huh? Have we defined a constructor inside of this class? Okay, so if there's no constructor, what happens when we create an object? What constructor do we call? Default constructor. And what does the default constructor set its values to? The default values. Yeah. So it's getting basically the default value of 0. Yeah, what's up?
Oh, you just said it.
Oh, okay. Yeah. So, okay, 5661 I think was what was said, right? All right, let's find out. Class versus instance. Java, class versus instance. 5661. Does that make sense to everyone? 5661. Actually thought it was going to be wrong, but then realized it was right. Does that make sense? Why? Because we have our static variable getting set to 5 here. So when we create this one, it's getting the same reference, which is going to be 5, and then we increment it, so that now becomes 6. And right here, we have our instance variables. This one got set to 6, so it printed out 6. And then this one got its default value of 0, and then got incremented, so it's 1. Does that make sense? What's up?
I'm not getting the same thing when I test that.
Because up here you have it's static. Right here I have it as an instance variable. Java doesn't lie. If I run this, it's not, like, when I run this, like, it can't be, like, wrong. That makes sense. Like, the Java's going to put out what I've made the code program to, so.
So why, so how come that A, how come when A is assigned to a test 2, it has that value of 5 and then it's incremented to 6?
Because we have it has a static variable up here, so all of the objects share the same instance of that variable A. So when we set A up here, we've set it inside of this class first instance class. So when we create another object, it's the same A, and then we increment it. Everyone good? Okay, so sets and maps or abstract class and overriding. By hands. Sets and maps. Abstract classes and overriding. Okay, sets and maps it is. Whatever. We'll get to them anyway. I should probably just go through them in order. Start a class. Oh my gosh. Oh, Jesus. Start a class. Here we go. Man. I hate how this is getting all jumbled up. So what I want you to do in this, inside of this main method, is I want you to read in a number n, and then read in n strings, and remove duplicates in order n time. But what that means is you can only spend a constant amount of time figuring out if you've already seen a string that you read in. So like you can't search through linearly all the strings that you've already seen to see if you've already seen that. You have to know pretty much instantly if I've seen that string or not. And then after that, I want you to read in a number m, and then I want you to read in m string integer pairs, so like a1, b2, right? I want you to read in m string integer pairs and map the string to the integer in order m time. If you've already seen the string before, update its value, basically. So if you see A1 and then A2, I want A to be updated to 2. But basically, what that means is you have to add and search to see if you've already seen that in constant time. What I mean by that is like, what constant time is like, let's say I have an array, and I want to go to the 5th index of that array. I can do that instantly. I just go to that point in memory. But let's say I have an array list of strings, and I want to see if I have that string in there already. looping through that array and comparing each string with the string that I'm looking for, that's considered an order n thing because you have to loop through those entire n strings to see if you've already seen it. So you have to know instantly whether or not you've seen this thing or not. So does anyone have any ideas? I mean, this is called sets and maps, so obviously it's going to be some kind of set or some kind of map. Does anyone have any ideas on how we can do this? What do you mean?
Create a set.
A set?
Yeah, a set, and they will automatically delete the duplication.
Okay, yeah. So what kind of set should we create? Because just a set isn't an instantiatable.
Set string.
A set, just a set isn't instantiatable. That's a like. So we have to create some specific kind of set. Array list aren't a set. What's that? A hash set. Remember earlier I said hash sets do things in like order 1 times. Hash sets are awesome. Hash maps are awesome. They do things really fast. We need a hash set here is basically what I'm saying. I want a hash set and then I want a hash map is literally what I'm asking you right here. So what do we use to read in things in Java? What do we use to read things in? What would you say? Scanner, yeah. So we use scanner. So right here we need a scanner. So let's say scanner in equals new scanner. And then what do we want to open the scanner on if we want to take in the information from the console? System.in. Yeah, awesome. Thank you. All right, so now we're reading in things. So we need to read in a number n, so int n, right, equals in.next int. Okay? And then now we need to read in n things. So what do we need to do to read in n things? A for loop. Yeah, awesome. A for loop, so then we'll say int I equals 0, I less than n, I plus plus. And we'll do something here. What did we say that we needed to do all this stuff in magical constant time? What did you say that we needed? A hash set. Yeah, awesome, thank you. So we're going to create a hash set. We're going to, inside of it, we're going to contain integers. We're going to call it whatever set, and then we're going to create a new hash set. There we go. So now we have a hash set. And then now we are going to loop through and read things in and add them into the set. And then you said that sets automatically take care of deleting duplicates, right? So if we add in duplicates, it's just going to take care of that. So that's basically taking care of this removes duplicates in order n time. Like this, it's literally doing that for us. So all that we have to do is say set.add and then I think I said strings, didn't I? String. So let's make that string, not integers. And then right here we'll do in.next.
What's the difference between the next and has next methods?
So next gets you the next thing. Has next tells you if there's a next thing. It's quite literally what it says. Has next is asking a question. Next is getting the next thing. Okay, so this is good. Is this good? Are we done? Does this do our first part of the problem? Is everyone happy? Yeah, we're good here. So, huh?
Yes, Vernon was happy.
Okay. So what did we need to do next? What was the next thing we needed to do? Then read in, so blah, blah, blah. See that, all right. Then read in a number m, right? So now we need to read in another number. So how did I do that? Someone tell me code. In.nextInt, but where, just like this, in.nextInt? Do we need to keep that?
Well, you can assign it to something.
Yeah, so we just need like an int m, and then equals in.nextInt. And then we basically need to do the same thing, but this time it's going to be a little bit more complicated because we're going to need to read in two different things. M I plus plus. So there's our for loop. What did we say that we needed? Well, actually, I said earlier, we need a hash map to do this, right? We're mapping things, so we needed a map. And then I said we need to do that instantly, like we need to do that very quickly. So we're going to need a hash map is basically what we're going to need. We're reading in string integer pairs and we're mapping. And hash maps actually take care of this thing that I've said where like if you've already seen this string before, update its value. If you put, so let's say we put like hash map.put the string A and the number 2. And then we put the string A and the number 3, it'll automatically know that we've already put our key A in there, and it'll just update its mapped value. So hash maps automatically take care of that for you. So right here we need a hash map, right? So hash map, and then what is this hash map containing? What? String and integers. What's that? Oh. String and integers. So string and integer pairs. Like when hash map, it's generic, it's key and then value for the generic. So the first thing is the key, the second thing is the value. And then we're just going to call this our map equals new hash map. Right? So then down here, we need to read in string integer pairs, right? So we could actually do this in one line, but let's not do that yet. Let's just do that. So how would I read in the string that we need to read in? Yeah. So you could say we could create a string temp equals in.next, right? Because in.next returns the next string that it sees inside of the thing. And then we need to read in an int now, right? So we could say int whatever temp2 equals in.next int, like we've done earlier with the int. So now we read in our thing, so now we just have to do, so with hash sets, you can just add things because you're just putting it inside of the set. With hash maps, it's not add, it's put, because you're putting a pair of things. You're saying this maps to this. Well, I want to put this in there. It's just like how it's been defined. In sets, it's add, and in maps, it's put. So hash map.put, and then we do temp, and then temp2, right? Because we want to map strings to integers. Yeah. So we're not printing anything out, but let's just compile, make sure that that is good. So that looks good. So we're still not printing anything out, but let's run it. And then we're going to pass it in. I've created a text file already called sets.in. This just has, hi, this is an example, and then some maps. This basically, like, when I do this arrow down here in the console, when I say arrow and then sets.in, it kind of wrapped over to the next line. It's saying, hey, take this file and pass it into this as if I was typing it into the console. That's all it's doing. So we run that, and we get no errors. So let's print out everything that's in the set. So we need to loop over everything that's in the set, right? I want to use the enhanced for loops. Someone tell me how I'd use the enhanced for loop to loop over our hash set.
For string s, set.
Like that?
I think so.
All right, we can always try it. So then for every string s, we want to print them out. So how would I print that out? Just each on the line.
Systemout.println s.
Yeah, awesome. Thank you. So there we go. I think that should work. So we'll just test that since we're at a stopping point. So there we go. We got hi, this is an example. So that just happened to be ordering. You're not guaranteed in ordering because it's a set. But you can see right here we had hi, this, and then to is. and then an example. So what we did is we did get rid of that is, which is what we wanted to do. All right, so now we need to loop over everything inside of the map, and I want to print out both like the letter and its mapped to value. You guys understand what I mean by that? Like I want to print out the string that is our key, and I also want to print out the mapped value that we've mapped to it. This is going to be a little bit more involved. I'm going to do the enhanced for loop again, but we have to loop basically over the keys and then get those keys values out of the hash set. So I'm going to say for string s in map.keys, I think it's key set. I'll have to check that. And then we want to print out system.out.println. And we want to print out the string, which is s, and then a space, and then we want to print out what that string has been mapped to. So how do we get something that has been mapped to inside of the map? How do we get something inside of the map? S.get value like this? What is S? S is our string, so we're saying string.get value, so we're getting the value off of the string. Map.get, yeah. So map, we want to get it from the map, and we want to pass it in our string S, or our key value. I think, please? Yeah. So there we go. We got A mapped to 6. We have B mapped to 2, C mapped to 3, D mapped to 4, E mapped to 5. And you can see right here we had A mapped to 1, B mapped to 2, C mapped to 3, D and E mapped to 4 and 5. And then at the very end, we mapped A to 6. So that's exactly what happened. We overwrote A to 6, and then we had the rest of the things didn't change. Good, good, good. Everyone understand what's going on? Basically, just think of like a hash set as just a set that's really fast, and a hash map is just literally like key value mapping that's really fast. Okay. All right.
Write that in one line when you're assigning stuff to the hash map.
Here, let me pull it back up.
Write it in one line. When you're adding them, that's where you put your in dot.
Oh, yeah. So I guess we can make that distinction. So right here, let me move the key. So right here, we decline a string temp, and we say int.next, so we get the next string. And then we define an int temp2, and then we say int.next int to get the next int, right? And then we use them both once here when we put. So do we use these variables more than once? We don't use them more than once. So when you're doing stuff where you don't use variables more than once, you can just like pass it on to where you're using the variable, basically. You can just eliminate. It's basically, you can think of it as like a middleman. Yeah, you would replace what this is being used where that is. So you would do right here, you would take this and you'd put it here, like that, and then you'd take this and you'd put it here where this thing is. And we don't need these anymore, so we can just get rid of them. And then we can also get rid of the curly braces because we're only doing one thing. So that looks nice and clean, and then there we go. Oh, and then I copied the semicolon. Oop. And it does the same thing. Yeah. So yeah, it's just like if you have things like that where you define variables and then you only use them once, you don't need the variable. You can just go put it wherever you're using the variable, if that makes sense. All right, moving on. So this is abstract class and overriding is what I call this example. But basically what I want you to do is I want you to declare an abstract class called employee, and give it an instance variable of type string and an identifier of type name, and then create a constructor for that class, takes in a string and sets the string to the name. And then I also want you to give this class a toString method that prints out the employee's name. And then I want you to create a second class called creatable employee that extends employee, give creatable employee an integer instance variable called ID, and create a constructor that does the things that we need it to do, and then overwrite the employee's toString method to print out both the name and the ID. It's like a really long-winded explanation for we're just going to create an employee class that's abstract, and then we're going to create a creatable employee that we can now use, basically. So how do I define our abstract class? We've already said it's name employee. How would I define an abstract class? The keyword abstract, yeah. So what would I type? Yeah, abstract class, and then what we wanted it to be called employee, right? Employee. And then what did we want to put in here? Then we want to give it an instance variable of type string with an identifier of type name. So that's basically just string name, right? There we go. And then we want to create a constructor for this class that takes in a string and sets the name of this employee to the passed-in string. So someone tell me how to write that constructor. You can just give me the method signature first. What do we have to do for the method signature for a constructor? Public what? Employee, and then, yeah, and then what did we want for our parameter? Yes, a string name, yeah. And then, so someone tell me inside of this constructor, how do I set the name of this employee to the name that we've been passed in?
This dot employee equals name.
This dot employee equals name, like that?
Or this dot name.
Yeah, it's not this dot employee, it's this dot name. Well, when you say this dot, when you say this, you're saying basically employee. When you use this keyword, you're saying the object I'm inside of right now, I want to set its variable to the, yeah. All right, and then give this a class, a toString method that prints out the employee's name. So public string toString method that prints out the employee's name. That doesn't, I meant returns this employee's name, basically. So that's just a typo. So what do we have to do in here to return this employee's name? It's very simple. Return name dot toString. Yeah, name's already a string, so you just don't have to call toString. You can just return the name. I think that will also work because I think string also has a toString, which. But anyways, yeah, you can just return name. Okay, is that it? Is that all that I wanted for that? ToString method puts out the employee's name. Yep, so that's it. That's our employee class. All right. So now we need our second creatable employee class that extends employee. So how do I do that? I said declare a second class called creatable employee that extends employee. Public creatable what? Is that it? Okay, extends employee public class. So, all right, awesome, thank you. Everyone think that's okay? Okay, there's something wrong here. Who can tell me what it is and why? No, we want this to be creatable. I don't want it to be abstract. We have two public classes. Does that make sense? You can only have one public class per Java file. That's just how Java's defined. You can only have one public. If a class is public, it has to be inside of a Java file with its name. So you can't create two public classes inside of the same Java file, so you just have to create a class. And it's implicitly packaged private. So because there's no identifier, right, we know that if there's no access modifier, it's automatically the default access, which is packaged private. So everything inside of this class and then everything inside of this package can access these classes that we've created, as long as this file has been compiled. Okay, yeah, so there we go. We have our creatable employee that's no longer abstract. I guess we could note that this doesn't have to be abstract because there's nothing in here that is abstract, but just for example purposes, we're making it abstract, saying, I don't want this to be creatable. All right, so what was the other thing that we needed to do? Give creatable employee an integer instance variable called ID and create a constructor for this class. Takes in a string and an int and sets the field and ID of this instance to their respective values. So just the first part of that, give creatable an instance variable called ID. Int ID, yeah, awesome. Int ID, there we go, ta-da. And then now we need a constructor for this class that takes in a string and an int and sets the name and field. So someone just give me the method signature of the constructor. Not you and not you. Someone else. Don't be shy. It's all good. Come on, someone. Come on, you literally have like a blueprint right here. You have a blueprint right here. Someone else tell me how I make this constructor down here that just takes in a string and an ID. Okay, yeah, sure. What's up? Were you raising your hand? I just didn't even see it. All right, whatever. Oh, okay, yeah, no, never mind, not you either. Someone else. Come on. I'll be here all day, whatever. Kyle, you got this? I want you to create a constructor for our creatable employee class that takes in a string and an ID. I just want the method signature. Yeah, I just want you to I just want this part of it. I just want this part. Public creatable employee, and it was a string and an int. Yeah, so string name, int ID, just like that. Was that so bad? What's up? So that was next. So what do I have to do next? Call super. Why do I have? So how would I do that? Super, just super? Like that?
Yeah. When you put in, you put in the parameters. In this case, it'd be maybe name.
Just name, right? Yeah. So can you explain to me what's going on there?
So when you call super, it's looking for the constructor in the super class for that object. In this case, it's employee taking a string called name.
Yeah. So basically, when you create a subclass, you have to initialize all the things in the superclass before you do your magic other down here in your subclass. So what you're saying there is, I extend employee, so I now have to go initialize all the things inside of employee before I can initialize the things inside of myself. Does that make sense? So super name, and then we can now do this dot ID is equal to ID. So we've called the superclasses constructor, initialized our name variable, and then we've called the, and then we've used our geez, what's instant or subclass constructor to initialize our instance variable. And I'm just going to make these public. I just realized if it's packaged private, I don't think the subclass will inherit it. So we'll just make it public just to make our lives easier. Okay, and then now we need to overwrite the employee toString method to print out both our name and our ID. Well, by print out, I just mean return our name and return our ID. So inside of our creatable employee, what do we have to do to make this toString method? No. Sorry. We've got a blueprint for it up here. We've already done this for employees, so we have to do almost literally the same thing.
You say signature, public string to string.
Oh yeah, we have the same signature, public string to string. Awesome. And then we want to return both our now our name and our ID, and let's say they're concatenated with a space in between. Any ideas?
Then return parameter ID plus name.
Well, I said I wanted the name and then the ID, so we would do name plus ID, right? And then we also wanted a space in between, so we'd also put a space. So we'd do name plus a space plus ID, like that. Everyone understand that the plus is string concatenation when you're using strings, and then addition when you're using numbers? Everyone know what string concatenation means? It's just like take the string, and mash them together. So the first one gets, or the second one gets put on to the end of the first one. It's just concatenating. It's just adding on to the end. So yeah, that should be good, I think. So now down here, let's just create an creatable employee. So creatable employee, A equals new employee, and then let's say I'm the employee, so Adam, and then we'll give it the value. I'll just be the first employee, and then system.out.println, and we're going to print out me, and we can do that because we've defined a toString. So Java C, actually. Java C abstract class is an overriding. Oh, okay, what'd I do? Yeah, I said employee right here instead of creatable employee. Employee isn't creatable. So, and also, it doesn't make sense for to create a creatable employee as just an employee, because a creatable employee is an employee, but employee is not necessarily a creatable employee. So I could do the other way around, where I had employee A is creatable employee, but you can't say creatable employee is an employee. Does that make sense? That's the general inheritance thing in Java. So yeah, so we do that. So now that should work. Yes, because an employee could be a creatable employee, but a creatable employee, I mean, I guess a creatable employee is an employee, but that's just kind of like, you can't do it that way because you've said creatable employee, so you have to have the stuff inside of a creatable employee. So calling just the employee constructor doesn't make sense. So yeah, Java C abstract class, it compiled, Java abstract class, and we get Adam 1. So there we go. Does everyone understand creatable, abstract, all this stuff?
So would it still work if we made the creatable employee's ID private? Why does that have to be public?
I don't think it has to be. It does. Yeah, you could make it private, and then you could make this private, and then you could also make the string up here protected. I think that should still work. Yeah, So that has to be protected because you want the subclass to have it, right? But you could make the creatable employees thing private because nothing's extending it, so nothing needs it. All right. Oh man, we're running out of time. All right, moving on. I really want to hit this generics example. Everything else kind of doesn't really matter, as easy, but this generics example I think is really good and really will help you guys with generics. You guys have seen it, but I'm changing it a little. So I have our public class container right here. Right now it just holds an int called my data, and then I've created a constructor that initializes our data. I've created a method that gets our data, and I've created a method that sets our data. Everyone understand? And also, this is wrong again. This should be void. It doesn't make sense to return something when we're setting. Don't understand. It's really a simple class. All it is it's just holding an int right now. That's all it's doing. Good? I want to make this container generic. I want to make this container hold whatever we want. So anyone have any ideas? You've seen this, right? Huh? Oh, you didn't? Okay. All right. Well then, okay. So how will we make this generic? Yeah. So up here we'd say angle braces, and then I like to use any type in here. Type. Yeah, it's just an identifier. It could be whatever you want. I like any type because it's just kind of like explicit. It's saying like this is a type, and it's specifically any type. Awesome, thank you. So that's made this generic, but right now our container still holds only integers. So someone give me one thing that we need to change to start making this generic.
Change wherever you see it, change it to any type.
Okay, so give me one place.
Private any type my data.
Private any type my data. Yeah, awesome, thank you. Any type right here. So I'm just going to copy this because I don't want to keep typing that. Where else? Someone give me another place. So just one place, just one. Public and get my data right here. We're going to be not returning an int anymore. We're returning an any type, right? Awesome. Somewhere else. Line 12? Yeah, so in our constructor, we're not taking in an int anymore. We're taking in an any type. Same at line 22. Yes, we're not taking in an int anymore. We're taking in an any type. Is that it? I think that's it. I think we've eliminated all the ints in here. So yeah, this should be good. So now, down here, what is, when you don't use the open-close angle brackets, what implicitly is inside of the generics? Like what implicitly are we saying that container can hold? Object. Yeah. Sorry, he beat you to it. When you don't put angle brackets, implicitly Java assumes that you have just angle brackets and object inside of there. So it's basically saying you can put whatever you want in here because everything extends object, right? So even like this container class extends object. Everything extends object even if you don't say it. So yeah, so implicitly right now we're saying this contains object and we're giving it an integer that's going to, or an int that's going to get auto-boxed in an integer. Integer is an object, so that's fine. But I want to be explicit, so how do I say this container is only allowed to hold integers? Yeah, angle brackets, and then what do I put inside of here? Integer, awesome, not int. You cannot put int, that's not okay. It's just the same as like an array list. You can't put, it has to be a reference type. So it has to be integer. Integer, there we go, my int. So let's do this a couple times. Now I want, all right, so I want this second one to hold a double. So what do I have to do to make it hold a double?
Write the word double in that wrapper.
Yeah, write the double wrapper class here. So double my int, and then right here, instead of giving it 5, we could give it 5, and Java would be fine with that because there's no loss of it. So that's, I guess, a good point. In Java, you can convert from integers to floats, from floats to doubles, because there's no loss of information. Java's fine with that. So if you say like double A is equal to 5 with no dot point, so just an integer, Java's fine with that. It can figure out that an integer 5 is just 5.00000. There's no loss of information. But let's say you tried to go from a double to a float. Java's not okay with that because there's not like enough, there's more information inside of a double than there is inside of a float, so you'll lose information. What's up?
What was that thing where you put the, oh yeah, casting, right.
Yeah, so if you want to do that and you know that you're okay with losing information, you can cast it. You can say, you know, if let's say I had,
What was that crazy math thing that we have to remember about casting from? Like he used an example.
oh, like division, I think is what you're talking about?
Yeah,
Yeah, so we can talk about that. But right here, so let's say we had our double A is equal to 5 point or whatever, it doesn't matter. And then int B, if we want it to be equal to the double A, we have to cast that A. So we can say A, but then we have to cast that A saying, I know that I'm losing information here and I'm okay with it. But if you were to go the other way, so if you were to go the other way right here and say this is equal to 5, and then set A equal to B, Java's fine with that. That's okay, because you're not losing information. You're just saying, I'm going to put this inside of a double. A double can hold more information than my int can, so it's fine. It doesn't matter.
What was that thing where if you divided a double?
Yeah, so if you divide an int by an int, so let's say we had int A and int B.
It's going to round off.
Int A and int B, if you do A divided by B, it's going to do integer division because you have two integers. If you want the actual floating point value of whatever your two things are, you have to cast one of them to be a double. So like that. So you'd have to put the whole thing in parentheses saying, I want to do this first, and then you'd have to cast that as a double. And then now you have a double being, or an int being divided by a double, so you'll get a double value. It'll go up all the way up to the double. Okay. All right. Little segue away. So now we have this double, my new container with a double, and now I want to do string. So I'll put string in here, and we'll just give it like Adam. And then now out.println. Where's that? Oh, thank you. Oh yeah, and then all these identifiers are the same, which doesn't make sense. So this, we could say this is my double, and then this is my, and this is my string. And it's good practice to camel case. So my double and my int. Was that what you were going to say? Yeah, and then also I want to put a toString method here just so that we can do that. So public string toString. Anyone have any ideas on how to make this return what's inside of my data as a string? Yeah. And the reason that's okay is because toString is actually defined inside of object, and everything extends object. So everything has a toString method, no matter what it is. It always has a toString method. So we can return the we can return the string representation of our data. That's basically what we're doing. We just want the string representation of whatever our data is. And then down here, now we can systems.out.println my int. And then we can do the same thing for my double. And we can do the same thing for my string. So Java C, oh, that's the wrong class. I think we're even in the wrong place. Let's just get rid of that. So Java C container.java. And it's complaining, oh, so that, when you see that, it usually means that you've defined something. We see how we've defined these to be specific generics. You see how we've said this is only going to contain integers, this is only going to contain doubles, this only contains strings. And then over here, when we call the constructor, we didn't mirror that. We just said just create a container. So it's saying, hey, that's unsafe. You've defined it to only contain integers, but then you've said just create a container with whatever. You said just create a container with object, basically. So what we need to do here is just put the brackets. So in the older versions of Java, you used to have to put integer there again. But now Java's smart enough to know that when you put those brackets, you're just saying, I'm being lazy and I don't want to retype it again, but use the thing that I've defined. You could retype it again. So if I really wanted to, I could put integer here, and it's fine. But doing this is the same thing as doing this because we've put it over here already. Java already knows. It's smart enough to figure that out. So I don't ever bother wasting time writing it out. And then I just do that. And then now that's gone. So then we Java our container, and we get 5.0 and add them. Good? Container, generics, awesome. Okay, so now let's turn this thing up to 11. Oh yeah, okay, what's up?
I have a quick question. When you say public any type, how do you know when you have to put the bracket thing, before and after any type?
What do you mean? Where?
So you have public class container, then you have the bracket, any type bracket.
Yeah.
And the second method below it.
Inside of here, we don't have any brackets, right? Is that what you're saying?
Yeah.
So when you're defining a class, the way to define that a class is generic is to use the angle brackets. And inside of the angle brackets, you put the type, you put the identifier for the type that you want to be there. Do you see what I'm saying?
Yeah.
So I'm saying our type, any type, and this any type is integer, it's double, it's whatever we pass in here. So you use the angle brackets to define that, and then afterwards it's just a regular identifier, and you just use it in place of a type. So right here we had int, right? Now we're putting any type. We're just saying this is no longer just an int, it's whatever we've been passed in, right?
That's only because we did it in the class, right?
Yeah, so just because we've defined it up here, we've said that this is a generic class, and we're going to give our class type the identifier of any type.
If the class wasn't generic, but the method itself was, then you have to do that in the method?
Yes. So you'd have to do that. Actually, let's do that next before we crank this up thing up to 11. So let's just create a generic method that I think he did the example of the max of 3 things that were passed in. So let's do a method that returns the min. So right here, I want this public something. So if we want this to be generic, what do we have to put here? If this is a generic method and we want this method to be generic, just let's also make this static. So this will be a little bit confusing. We're throwing in a static method into a class that we've been creating stuff for. It's fine. We want this to be a public static method. We can just call it. And then we also want this to be generic, and we want it to return the min of 3 values that have been passed in, but we want those 3 values to be of any type. To not be of specifically the any type, this any type. We want this to be whatever we want. We just want to be able to call it and just be anything.
So it's public static bracket T.
Sure, yeah. So public static bracket T. And then it's going to return what? What thing is this method going to return? Yeah, T. Public static T, min, and then it's going to take in tx, yeah, so T, let's just call it A, T, let's call it B, and T, let's call it C. And then inside of here, so to be able to do this, what do we need? What do we need to be able to do with that generic type?
Compare.
Yeah, you need to be able to compare them. So what do we have to define this to do? Yeah, implements. Well, so when you're doing this, it needs to extend. extends comparable. It needs to extend comparable. And then inside of here, what do we need to do with the three things? So we could do T min equals A, right? And then now we could do if T dot compare, or if min dot compare to B is less than 0, so that thing comes before this thing, min equals B, and then we can do the same thing, min dot compare to C. If that's there, then the min is now C, and then we return min. So that should work. Java C container, unchecked or safe operations. I'm not quite sure what that is, but let's just try. Huh? No, because we're not, we're defining this right here. So let's just call it, I've never actually made a method that is specifically generic. So let's just say min of 5, 6, 7, right? System dot out dot println. Let's print it out. So min of 5, 6, 7. Five, 6, 7. So I guess I got this logic backward. We got the max, so we want to do it this way. I always get those two mixed up. And then we got 5. Yeah. And we're actually pretty much out of time. So
Real quick, with the generic method, can you put the angle brackets before the return type?
well, I don't think so, because you need to define this type before you can know that it's what to return. I don't think so, no, because then it parses left to right, so it doesn't really make sense to do that. Everyone understand? Good with that? I'll post this. If you really want to crank this up to 11, make this container class sortable. Make the container class sortable. So if you really I've already done that, and I've posted it in my last my exam 3 review. So if you guys want to see how to do that, or you want to try it on yourself and then go look, go to my website, ucfsi.wordpress.com, and it's on there under my exam 3 review. But other than that, any other questions? Everyone good? Okay, we didn't get through everything, but that's kind of how it is. I had a little bunch of stuff, but thanks for coming.
Hey,
I'll see you guys later.
We have to send
I just write the.
No.